topic number first, laws of motions. Our surrounding, several objects are in a moving position, like running of car, flying of birds, runnings of children, and some objects are in a brisk position, like big rock, mountain, trees are in a stationary position. Then what objects we can see, or we can say that a moving objects, then which objects displace their original position to the another position. That's we can say that this is the moving objects. Then we have to see the difference between distance, displacement and distance. Then which are the displacement and which are the distance? That's the some examples in that. Distance is the length of actual path traveled by an object in motion while going from one point to another, whereas displacement in the minimum distance between the starting and finishing point. We have to differentiate of that distance and displacement. Displacement is the minimum distance between starting position to the last position, and distance is the total actual path traveled by an object in motion while going from one point to. Student, see on your screen. In that screen, we have to see that's the pictures of homes of Sheetals and Prashant house. At that position, a distance of Sangeeta's house 500 meter, and the distance between the Sheetals and school is 1300 meters, and the distance between Sangeeta's house and school is 1200 meter. Path A, path B. Path A denoted that the 500 distance of Sheetal and Sangeeta. Then Prashant went straight from home to school. Both are walking with the same speed. Who will take less time to reach the school? And in the above example, is this a difference between the actual distance and the distance traveled? Sheetal first went to her friend Sangeeta's house on her way to school. See on your screen a circular ground. That's the point A. Swarali walks around the edge of that circular field, having a radius of 700 meter. As shown in figure, if she starts from point A and takes one round, how much distance? That's the 4500 meter he walks around that circular ground. But that displacement is the difference between starting position point A and ending position also point A. Then the displacement is 0, but distance is total path traveled by a Swarali is 4500 meter. Take a second example and on a second picture, that the car starting from point P traveled to point Q at a 360 meters. That the distance is a 360 meters. Also displacement also 360 meters. But when a car coming back to the point P, then the position of point P and last position of car is also point P. Then displacement is 0, but that distance is total traveled by a car is 360 meters to the point P to Q, and point Q to P also 360 meters. Then total distance traveled by a car is 720 meters. Velocity of changing of the direction, that's the 3 stages. At first stage, changing the speed while keeping the direction same. At the second stage, changing the direction while keeping the speed same. And that the 3 stage, changing the speed as well as the direction. The changing of direction is affect on a speed. Then we have to see on picture on your screen. That first picture, that Sachin travels in a straight way at a same speed, but at a second picture that rotate from because of that road. This affects that the speed because of that direction of the bike. Also, in a third stage, that's a changing of their speed and the direction as well as. Then the direction of that object is affects from an non-uniform linear motion. Amar, Akbar and Anthony are three friends. Travels to the car to the at ending point. Ending position is the same, but that's the time required for that three cars reaches at end point is difference because of that non-uniform linear motion. That's the difference of uniform and non-uniform is uniform is that an object covers equal time required in a equal distance. That's the uniform motion. What is the non-uniform motion? Linear motion. Non-uniform linear motion is an object covers unequal distance in unequal time intervals. That's the difference of uniform and. See on your screen time in the clock at that first column. At the second column, distance covered by Amar in kilometer, distance covered by Akbar kilometer at the second column, and last column is the distance covered by an Anthony in a kilometer. That Amar spending equal time interval at the equal distance traveled, but that the Akbar traveled unequal distance and equal time. That's the difference of uniform and non-uniform linear motion. Amar travels in an uniform motion because equal time interval also in equal distance, but Akbar and Anthony spend equal time but in unequal distance. That's that non-uniform motion. It is the example of uniform and non-uniform motion. Easily we can define that if an object covers unequal distance in equal time intervals, it is said to be a non-uniform motion, and if an object covers equal distance in equal time, that's a uniform linear motion. Acceleration. What is the definition of acceleration? The rate of change of velocity is called a acceleration. See the formula. Acceleration. Acceleration is the ratio of change in velocity with time. At change in velocity, what is change in velocity? Velocity as the final velocity minus initial velocity in that time. This is called as the acceleration. Students, here we have to see a graph of uniform motion for distance time graph. Its table indicates that equal intervals of time. Also, objects travel equal intervals of distance. That's graph is called a distance time graph for uniform motion. Also, another graph indicates the distance time graph for non-uniform motion. You can see on table that time intervals are same, but object travels a distance of an unequal intervals of distance. That is called as non-uniform motion graph. Also, another graph indicates the distance time graph for non-uniform motion. You can see on table that time intervals are same, but object travels a distance of an unequal intervals of distance. That is called as non-uniform motion graph. Here a graph of velocity time graph for uniform acceleration. You can see on table time intervals is equal, say 0, 5, 10 up to same intervals of a 5 second. Also increases of velocity with equal intervals. Then we can draw a graph on x-axis time second and y-axis denoted velocity also increases. On that graph you can see time increases with increases of velocity. Then that's graph line is in a straight line. Students, we can learn at finding of equation by an graphical method. Total 3 equations. That first equation, the relation between velocity and time. That the second equation denoted that the relation between the displacement and time. And third one is the relation of displacement and velocity. Let's see, that's a finding of first equation of that first graph. On that graph you can see the velocity on y-axis, also time on an x-axis. On that graph velocity increases with time increases in equal intervals. Then we can say that this is a uniform velocity. We have to formula acceleration. Acceleration is the ratio of change in velocity with time intervals. That's the formula. You can say that final velocity decreases that the initial velocity. That then the difference of final velocity and initial velocity is on graph line CD indicated by an AT. You can say the final formula is V is equal to U plus AT. And that formula, V is a final velocity, U is a initial velocity, and A is a acceleration with time intervals t. This is the first equation of motion. Here we have to find Newton's second equation of motion. Equation describing the relation between displacement and time. In that equation you can see on a graph that the area of quadrangle is equal to area of rectangle DOEA plus area of triangle DAB. On that summation of two area, that's rectangle and triangle, then is equal to area of quadrangle DOEB. That is a displacement of that object. That displacement calculate that the product of initial velocity and time plus half of products of acceleration with square of time. That's the formula for the Newton's second equation of motion. Here we have to find Newton's third equation of motion. Equation describing the relation between displacement and velocity. On that finding of equation, also the formula for the displacement is equal to area of trapezium DOEB. On that area of trapezium we can calculate the half of the multiplication of sum of length of parallel side and distance between the parallel side. On the finding the equation value, then you can say the final formula for the Newton's third equation of motion is V square is equal to U square plus 2AS. At that time you can see the three equation of Newton's first equation is V is equal to U plus AT. This equation is the relation between velocity and time. That the second equation, S is equal to UT plus 1 half AT square. This is the relation between displacement and time. And the last and third equation is V square is equal to U square plus 2AS. This is the relation between displacement and velocity. Thank you.
First question is, clarify the difference distance and displacement. Define uniform and non-uniform motion. Third question, write the three equations of motion. And fourth question, describe the equation of motion using graphical method. Solve a answer in your science notebook.